All right, we are reviewing for our final exam. These questions come from chapter 1. We've talked about different sets of numbers. The natural numbers are numbers 1, 2, and 3, etc. Your counting numbers. If we add in 0, we have whole numbers. Adding in our negatives gets us our integers. Going out one step further, anything that can be written as a fraction or a terminating decimal is considered a rational. If it can't be written as a fraction or a terminating decimal, it is irrational. So things like pi or square root of 2. All right, all of those subsets make up our real numbers. So how would we classify the square root of negative 15?
Irrational.
All right, irrational. We said square root of 4 would be what? The value of 2, right? Think of it in its simplified version, which would make that a natural number. Okay, so don't assume that all numbers that have square roots on them are irrational. You have to think about what their exact value would be. How about 0.75? That is rational. Could be written as 3/4. All right, a ratio. So those are rational numbers. Negative 12 is an integer. And just a 4. Natural. Okay. All right, our next learning target was just being able to write algebraic expressions. So taking words and converting them to an algebraic expression. So 3 times the sum of A and B. What does sum mean? Addition. 3 times something means that, right? We're multiplying something by 3. And it says 3 times the sum of A and B. So we are adding A and B together. Okay. 4 divided by, so 4 divided by something. And then we're dividing by, it says the difference of x and y. Difference means that we're subtracting. So we have to subtract x and y and divide by that quantity. The product of 2 with the difference of r and t. What does product mean? Multiplication. We said difference means subtraction. So we are multiplying 2 with something. Okay, we're doing the product of 2 and something. Then something part is the difference of r and t. So r minus t. Quotient means what? Does mean division. All right, so we have a division problem. What would go on top? It says the quotient of 5 and the sum of d and 2. What goes on top? The 5. All right, we want the quotient of 5 and the sum of d and 2. All right, next example says Brooke collects spoons from places she visits. She already has 15 and she collects 4 more every year. Write an expression to model how many she has. All right, so if we say x equals number of spoons,
Yeah, I know what it is.
how can we write an expression for this?
X would be number of years.
Thank you.
Silly.
How many does she start with?
15.
Starts with 15, and then what do we do to that 15?
Plus it adds to 4x.
We add 4 every year. Okay. Keep in mind, we are just talking about expressions here. There's not an equation. It doesn't equal anything. Alex has saved up $300 in his bank account, but spends $20 a week on gas. Write an expression to model how much money he has in his account. What would our unknown be? Weeks? Okay. So how much does he have at the start? 300. And what are we going to do to that 300? Subtract 20 every week, so 20x. Questions on that learning target? All right, I can solve linear equations. Again, we skipped over some of this basic solving when we started our semester, but I do want to review a couple things. Solving for x. Remember, whatever you do to one side, you have to do to the other. So if I subtract 1, I have 2x equaling negative 10. What would I do next? Divide out the 2, and x would have to be negative 5. Remember, if it's a test question, you can always plug that back in and check it, make sure it works. Okay. What do we have to do on this next one? One option would be to distribute the 3. Is there another option? Since this whole side is being multiplied by 3, we could actually divide it to the other side. And it divides into 12 nicely, so that's probably going to be faster. If it hadn't divided in nicely, or maybe there was some extra pieces and it wasn't the whole side being multiplied by 3, then we would want to distribute. So now we have x plus 2 equaling 4, which means x has to be 2. All right, next question. We have variables on both sides. How do we get them on the same side? You actually can move either one.
Yeah, I mean, like, you, do the opposite to the other side.
Okay, so we could subtract 3x. That gets me 1x plus 5 equaling negative 1. And since I brought all the x's to the left side, now I have to bring my constants to the right side. So subtracting our 5. Whoops, negative 6. Okay. All right. Our next question. Would it make sense to divide both sides by 2? Not on this one, because 2 doesn't go in nice and evenly to that other side. So let's go ahead and distribute. We get 2x minus 4. And then it's just like the last one we did. Okay, we're going to bring the 2x to the other side. That gets me 3x plus 2 equaling negative 4. Then what? Subtracting 2 over, so 3x would be negative 6. Last step. X has to be negative 2. Okay. I'm going to pause the recording. I want you to do the next one on your own. All right, checking our answer. First thing we do, distribute the negative sign. Then I need to combine my x's onto one side. I added 3x to both sides. Then adding 1 to the other side, I end up with x being negative 3. Okay? Last question's a little different. We have a formula here. A equals 4b divided by c, and the question says to solve it for b. You're not going to get a nice number answer. You're just going to get a revised formula. Okay? So if we want to get b by itself, what would we need to do? We somehow have to move the 4. We somehow have to move the c. Let's start with c. It's being divided on this side, so what do we have to do? Okay, so multiply both sides by c. So a times c equals 4b. And then we can divide our 4 over. Okay. Any questions on that target? All right, our next learning target. I can evaluate expressions or functions. So our first one, we have the expression, how would we classify this?
Polynomial.
It's a polynomial with 4 terms, right? What about the degree? Cubic, right? Degree 3 would be a cubic. So this is a cubic polynomial. They're asking me to evaluate when x is 2. You need to be very careful with negatives here. We are taking our x and replacing it with a 2. So you need to just replace all of your x's with empty parentheses as your first step. Okay? Then you can go in and dump in the 2 that you are supposed to be evaluating for. Okay? In this first term, the 2 is being cubed, which makes it an 8, and then we tack the negative on. So now we have a negative 8 here. Our next term, powers first, 2 gets squared, making it a 4, and 4 times 3 is 12. Our next one, we've got negative 2 times 2, which makes a negative 4. And our last term, we didn't have to change. Okay, so we've dealt with all of our powers first, then we did any multiplication. Now we can do our adding and subtracting just in order from left to right. So negative 8 plus 12 would be 4. 4 minus 4 gets us to 0. And 0 plus 5 is just 5. Okay. All right, I'm going to pause the recording. I want you to try the next one. All right, our next question, we are evaluating for negative 1. So I've put negative 1 in for all my x's. What is negative 1 if we cube it? It's still negative 1, and then negative 1 times 3 gets me negative 3. Negative 1 squared, positive 1 times negative 2 would be negative 2. 4 times negative 1, and then we're subtracting 7 at the end. So negative 3 minus 2 is negative 5. Negative 5 minus 4 more puts me at negative 9, and negative 9 minus 7 more gets me a negative 16. Questions? All right, the last two are really the same thing. They've just put it in function notation. So they're saying f of x equals 3x minus 4. We want to find f of 2. So they're just telling us to replace our x with a 2. All right, so if we put a 2 in for our x, what does it simplify to be? Okay, so f of 2 is equal to 2. All right, our next one, we're finding f of negative 5. So you're just going to replace your x's with negative 5 and then simplify. So negative 2 times negative 5 is positive 10. Adding our 7 gets us 17. Now, keep in mind that when you are evaluating something like this, you're really finding an ordered pair. So we put a negative 5 in for x, we're getting a 17 out for y. Okay? All right, last question for this learning target. It says you're ordering binders for school online. Each binder is $2 and there's a shipping fee of $7. Write an expression to model the cost and then evaluate for buying 6 binders. Okay, so we need a cost function. Okay, x is going to stand for what? Okay, number of binders. So the cost of those binders, each binder is how much? Each binder is $2, and then we have to pay an extra what? 7 for shipping? Okay, so that is my cost function. Then it says to evaluate it for what? All right, so if I buy 6 binders, I'm going to pay how much? $19? All right, any questions on that learning target? All right, that was a quick overview of Chapter 1. Moving on to Chapter 2.
So that's like everything in Chapter 1 is going to be in the final.
That is an overview of Chapter 1 for your final, yes. So we've reviewed the topics that you would see on your final.
How many questions are in the final?
Final is 50 questions total. All right. First objective here. guys? First objective is to talk about domain and range and being able to identify them. Domain are your x values, range are all your y values. The note here says when your relation is distinct points, like you see below here, you are only listing the x and y values that you would have seen in those ordered pairs. Okay? If an x or y value is repeated, showing up twice, you don't list it twice. It still just shows up once in your domain and range. Okay? So for our first example, we said domain are all of your x's. We put it in set brackets. So we want to list all the different x values that are being used. Okay? So let's start on the farthest to the left. We have this point B, which uses -4 as an x coordinate. Okay? Our next point, D here, uses a -3. Okay? E uses 0 for its x coordinate. A uses a 2. And F here uses a 7. Okay? So I've listed all the x values that are being used. Then for my y values, for my range, do the same thing. Start lowest and work your way up. So my lowest point is F here. It's using -5 as its y coordinate. Next would be D, which uses -3. Next highest point is E here. Y coordinate is 2. B has a y coordinate of 6. And A has a y coordinate of 7. Okay? Now, you have another option. You could certainly list all your ordered pairs and then separate, put your x's in the domain, put your y's in the range. You can do that as well. Okay? I'm going to pause the recording. I want you to try the next one. All right, checking your answer. Domain, we have -1 and -3. We have a lot of points, but some of them are at the same x coordinate. Okay? So we're really just using a -1 here for A and E, and all of these are lined up at a +3. Okay? Your range, there's only 3 different levels, -5, -3, and +2. All right, next learning target. I can determine if a relation is a function. You guys remember the vertical line test? Okay? If we draw a vertical line anywhere in the graph, it can only hit once, right? If it hits multiple times, it's not a function. So, is the first one a function? Yes. Okay, we can say it passes vertical line test. How about the second picture? This would be a no, right? Here's an example. Vertical line hitting 2 spots. Okay? So, not a function. Fails vertical line test. All right. Our next topic in Chapter 2 was how to write equations for lines. And we had several different forms. We have point-slope form, we have slope-intercept form, we have standard form. You need to be able to go back and forth between them all. Okay? Point-slope form is listed here. The y1 and the x1 come from that specific point that you're given that your line has to go through. Okay? M is your slope. You might be given that. You might be asked to find that. All right, so for our first example, write the equation of the line that goes through the 2 given points. So given 2 points, my first step is to do what? Find the slope. All right, here's our slope formula. Okay, so finding our slope, we need to subtract our y's. Okay, so 6 and 4 are my y coordinates. I can subtract them in either order, but once I pick an order, I have to do the x's in the same order. So if I go 6 minus 4, I have to do negative 1 minus 2 on the bottom. So my slope becomes what? Negative 2/3? Okay. They're asking us to write an equation. It says point slope form. So we are going to pick one of our points. It doesn't matter which one. Okay, so I'm going to pick the point 2, 4. If this is a multiple choice test, which your final will be, maybe they chose the other point, negative 1, 6. Okay, so just keep that in mind. You can come up with an equation with using either point. So y minus my y coordinate. I'm using the first point here, so my y coordinate is 4, equals my slope times x minus my x coordinate of 2. Okay, and if they want it in point slope form, you're done. Okay, you put it in that form, there's nothing to simplify. All right. Next form was slope intercept. M is your slope, B is your y-intercept. It says if you're asked to put an equation in slope-intercept form, essentially you're being asked to solve for y. So we could have taken that answer we just came up with on the previous question, and we could have solved for y. All right. How do we write this one? What form is it in to start with, by the way? That is standard form. We want to solve for y, so what would we have to do? Okay, add the 5x to the other side. And then divide everything by 2. Okay? What would be my slope? Slope is 5/2. Y-intercept? 3/2. Yes? Okay. Parallel lines. Sometimes you'll be asked to write an equation for a line that's parallel to a given one. What do we know about parallel lines? They have the same slope. Okay, so in our question here, we've got write the equation for the line that's parallel to y equals negative 2x plus 1 and goes through the point 1, 3. So what slope do I want to use? I need to use a negative 2. That's the only thing I need from that equation. Okay, now I ignore this. I know my slope is going to be negative 2, and I don't have to worry about that. So same thing we did before. Slope is negative 2, point is 1, 3. Okay, so starting with point slope form, we've got y minus our y coordinate of 3. Our slope is negative 2, and we have x minus our x coordinate of 1. Okay? Now again, it's going to be a multiple choice test. If you don't see that choice on there, what might they want you to do? They might want you to simplify it and put it in slope intercept. So distribute our negative 2 and add our 3 over. Okay? Questions on that? What if they had said the lines are perpendicular? Slopes are opposite and reciprocal. So you have to flip it over, right? And then you have to change the sign. So if this had been my original equation, but I wanted it to be perpendicular, what would I have used for slope? I'm going to flip it over, so 1 over negative 2, and then I'm going to change the sign. I'd use a 1/2 instead. Yes? Okay. Let's try to do one more target here quick. What form is this? Standard form? All right. So how do we write an equation in standard form? Your variables are on the same side. This is key. No fractions. No fractions. So if you have fractions, you're going to have to multiply by your common denominator to get rid of those. Okay? So for this one, we've got y equals 2/5 x minus 3. Right now it's in slope-intercept. We need to convert it to standard. I don't care if you get your variables on one side first and then deal with fractions, or you get rid of the fractions first and then move your variables. Okay? You have to do both steps. If we tried to get variables to one side first, the 2/5 x is nice on this side because it's positive. So I'm going to leave it there. But I need to move the y over here. And I need to move the -3 over to that side. Okay? So I'm going to subtract y to put it on the side with x. And I'm going to bring the -3 to the other side by adding it over. Okay? So I have my variables on the same side. Then what do I need to do? Yes, I need to multiply everything by 5. Okay, that's going to get rid of my fraction. 5 times 3 is 15. What about 5 times 2/5? Okay, so I just get the 2x, gets rid of that fraction. And then 5 times -y. Okay. All right. The last piece, when we are looking at things in standard form, easiest way to graph them is to find x and y intercepts. Okay, so x and y intercepts, my x-intercept is the value for x when y is 0. Okay, my y-intercept is the value for y when x is 0. All right, plugging in a 0 for y, this goes away, and I have 2x equaling 18, which means x is 6. My x-intercept is 6, 0. Sorry, I read it wrong. I saw the 9 there. Okay. Thank you. All right, there we go. And then put a 0 in for x, we get, this goes away, we get -2. All right, and then we could just connect them, make our line. Yes? All right.